Okay, so this is part 2 of section 3.1, and so now we're going to talk about standard form of a quadratic function. And so if you will fill in with me on your note page here, fill in the blanks with me here as we talk about it. A function f is a quadratic function if f of x equals ax squared plus bx plus c, okay? Where a, b, and c are real numbers with a cannot equal 0. Okay, and so when it's in this form, the vertex is going to be the h part, or in other words, the x part of our vertex, because remember our vertex is always hk for this parabolas. The h part of this vertex is going to equal whatever we have, negative b divided by 2 times a. So that's how we'll find the x part of our vertex for these. And k equals f of h, and what that really means is that once we find this h value, this x value, we plug that back into our function and solve for y, and that gives us our k. So it'll probably make more sense as we work actual examples, okay? So this first example here of graphing a quadratic function that's in standard form, it tells us to graph each quadratic function, give the required information for each parabola. So this looks familiar from the other two examples that we've already worked. But notice again that the quadratic function, this time the equation is given in standard form instead of that vertex form that we've already worked through. So we have f of x equals, which remember is the same thing as y equals x squared minus 10x plus 21. So first of all, I notice here my a is understood to be a positive 1, so let's list that. B is negative 10, and C is positive 21. And since my A here is positive, then that means that this parabola should open up. So we've answered the first question here. Direction of opening, since A is positive, it should open up. Okay, so to find our vertex, that's where this information back up here in our box is going to come in. For the vertex, h, remember, is going to equal negative b divided by 2 times a. So if you want to make some notes here, you can put that to find the vertex, when it's in standard form, we start with x equals negative b over 2a, or in other words, the h part, which is really the x part of our vertex. So x equals negative b divided by 2 times a. So we go back up here where we've listed a, b, and c, and we say x equals negative, that's really negative 1 times negative 10 divided by 2 times a, and a was 1. Well, negative times negative makes that positive 10, divided by 2 times 1 is 2, so x equals 5. So right now, I know that my vertex, the x part of my vertex, h in other words, is 5. Okay? So now I'm going to take this 5 and plug it back in for x back into my equation to find y, because remember f of x equals is the same thing as y equals. So this was step 1 of finding the vertex. So step 2 is to now take this value we found for x and plug it back in for x into our equation. So y equals, and we're plugging it back in here, so that would be 5 squared minus 10 times 5 plus 21. So y equals, I squared that first, 5 squared is 25, minus 10 times 5 plus 21, always follow order of operations. So that's 25, negative 10 times 5, that's minus 50 plus 21. And so that gives us 25 minus 50 is negative 25 plus 21. I subtract and keep the sign of the larger number, y equals negative 4. So now I can finish out my vertex. So my vertex is 5, negative 4. Okay, so axis of symmetry. Let's go ahead and graph this one on our graphing calculator. So if we go to y equals, clear anything else out that was in there. So we're going to clear that last one out. And then I'm going to type my equation here, for example, a, into my calculator. So go to y equals, and we're going to type in what we have here. So that's x squared minus 10x plus 21, enter and graph. Okay, and so we remember that the axis of symmetry is this vertical line that would run through the vertex, okay? And because it's a vertical line, that means the equation is going to be x equals, and remember it's whatever x value you have in your vertex. So our axis of symmetry is x equals 5. Okay, x-intercepts, if any, well, we can definitely see from this graph on our calculator that yes, we do have two x-intercepts, two places that this graph is crossing the x-axis. And so to find our x-intercepts, okay, and I'm going to get another sheet of paper so I have a little more room, but to find our x-intercepts, remember that you let y equal 0 and solve. Okay, so if we go back here to our equation, remember f of x is the same thing as y equals, and so if we look at our equation, so instead of putting y equals here, we're going to let y equal 0, and we're going to put in 0 there, equals x squared minus 10x plus 21. And remember, we've already identified a, b, and c, so I'm going to use my quadratic formula to solve this. That's how we solve a quadratic equation. And I'm going to actually use quad 4 on my calculator. So you, if you have quad 4 program on your calculator, you are welcome to use it. And if you don't, you would have to use quadratic formula, pencil and paper method. Okay, so quad 4, hit enter again, and we've already identified that a is 1, b is negative 10, and c is 21. Enter, and so hit enter again, and it tells me that we have x-intercepts. It tells me on my calculator screen that x equals 3 and x equals 7. So that means, remember, we let y equal 0, so the ordered pairs would be 3, 0, and 7, 0 for my x-intercepts. And so I'm going to put that in my blank on my sheet, okay? So my x-intercepts are 3, 0, and 7, 0, okay? And I'm going to go ahead at this point and sketch my graph because I have more than enough information now to sketch it. So my vertex is 5, negative 4. We know it opens up, so that would be 5 to the right and down 4. Okay, and then we could plot these two intercepts, 3, 0, and 7, 0, to get a more definite sketch there. So let's do 3, 0, 7, 0, and we will sketch our graph. Sketch our parabola. Okay, so remember to find our y-intercepts, or y-intercept, I should say, just one of those. Remember, for that, we have to let x equal 0. So to find a y-intercept, let x equal 0 and solve. And so again, I'm going back to my equation that was given to me, and I'm going to plug in 0 for x. So remember, f of x is the same thing as y equals, and so I would have 0 squared minus 10 times 0 plus 21. Well, 0 squared is 0, minus 10 times 0 is 0, so this is really just 0 plus 21, or y equals 21. So remember, we let x equal 0, so 0, 21 would be my y-intercept. And so I'm going to put that in my blank here on my paper. Okay. Our domain, remember from the other previous examples we've worked already in this section, the domain of the parabolas that we cover in this course is always going to be negative infinity to positive infinity. And our range, remember, since this one opens up lowest to highest, y values is what we're talking about when we're talking about the range. then I'm going to start with my k value, or in other words, my y value in my vertex, which is -4, and we want to bracket around -4, comma, and it goes up forever and ever, so to positive infinity with a parentheses, okay? And so I filled in all the information for example A when the equation or the function is given to us in standard form. So let's look at the next example, last example for section 3.1. Okay, and so again we see that this is given to us in standard form, and so we're going to do A equals -1, just identifying our A, our B, and our C. B is +2, and C would be -4. And because A is negative, we know the direction of the opening should be down. Okay, since it's not given to us in vertex form, we're going to use x equals -b divided by 2 times A, and that's to find our vertex, okay, since it's in standard form. So x equals, and so we would do -1 times 2, or -2 divided by 2 times -1. Well, x equals -2 divided by 2 times -1 is -2, and -2 divided by -2 is +1. So we know that our vertex, the x part at least, is 1. So now we need to find the y part of our vertex, and so to do that, we plug 1 back in for x, back into our original equation. Because remember, f of x equals is the same thing as y equals, and this negative here in front of the x squared we can write as -1 times x squared, or -1 times 1 squared, plus 2 times 1 minus 4. So y equals, do order of operations, we square 1. 1 squared is 1, so we have -1 times 1 plus 2 times 1 minus 4. -1 times 1 is -1, 2 times 1 is 2, minus our 4. -1 plus 2 is 1 minus 4, and 1 minus 4 would give us -3 for y. So our vertex is 1, -3. Okay, remember our axis of symmetry is the vertical line, so it's x equals, and it's whatever our x value is in our vertex. So x equals 1 would be our axis of symmetry. Okay, let's go ahead and graph it on our graphing calculator. So go back to y equals, clear anything else out, and let's type in our equation. So y equals, and use your negative key, x squared plus 2x minus 4, enter and graph. Now, since this one opens down, and our vertex is here below the x-axis, we can see that this graph is not going to ever cross the x-axis. In other words, it does not have any x-intercepts. So for x-intercepts, we will put that it has none. Okay. All right, our y-intercept, we would have a y-intercept, and remember to find our y-intercept, you let x equal 0 and solve. So that means, remember, f of x equals is the same thing as y equals, and that's really -1 times x squared. So -1 times 0 squared plus 2 times 0 minus 4. Well, 0 squared is still 0. 0 times -1 is 0. 2 times 0 is 0. So you really have 0 minus 4, or simply y equals -4. And so since we let x equal 0, the ordered pair would be 0, -4. That is our y-intercept. Okay, at this point, I'm going to go ahead and I can graph it. And so my vertex is 1, -3, so that's 1 to the right and down 3. I know my y-intercept is 0, -4, so I simply go down 4. And then we could go to our table of values. Second graph pulls up your table of values if you need some more points to kind of get it in order there. But 2, -4, because it's symmetrical through that vertex or about that vertex, the axis of symmetry, remember, is x equals 1. So that gives me another point here on the other side that you can get that again from your table of values. 2, -4 is also another point on that parabola. And so we have a sketch. Domain again would be -infinity to +infinity. And our range, since this one opens down, our range will start with parentheses -infinity, comma, up to our highest y value. In other words, whatever your k is in your vertex, or in other words, whatever your y value is in your vertex. So that's -infinity, comma, to -3 with a bracket around -3. Okay, that finishes up all of the examples for section 3.1. Now you should go to your textbook and try the following odd exercises. Do parts A through D only for each problem. They're found on page 293 in your textbook, and you can check the answers in the back of your textbook since those are odd.